Trigonometric integrals. In this video, we're going to see how to integrate powers of secant and tangent. Alright, in order to do these, we need to recall some things. First, that the antiderivative of tangent x is equal to the natural log of secant x. That the antiderivative of secant x is the natural log of secant x plus tangent x. And we need to remember the Pythagorean identity of 1 plus tangent squared x is equal to secant squared x. Let's start with an example. Let's evaluate the integral of secant cubed of x. Alright, we're going to do something very familiar. We're going to peel off 2 powers of secant x and rewrite them using the Pythagorean identity. Now what we're going to do is distribute the secant x across the parentheses to get this integral of secant x plus the integral of tangent squared x secant x. Now the integral of secant x we just said was equal to the natural log of secant x plus tangent x. So now what we need to do is evaluate the integral of tangent squared x secant x, and we will do that by peeling off a power of tangent x. So we'll rewrite it as tan x secant x times tangent x. And then we're going to use integration by parts. We will let u be equal to tangent x, so this first one, and dv be equal to secant x tangent x dx, which is this part here. Doing so gives us that du is equal to secant squared x dx, and v is equal to secant x. So this equation becomes this one, where I'm replacing the integral of tangent x secant x tangent x dx with tangent x secant x minus the integral of secant x secant squared x dx. Now simplifying this gives us this, and here if you look, our integral is the integral of secant cubed x dx. That's interesting because that's the integral we started with. So just like we did in the previous video, notice that this term and this term are the same. So I'm going to bring them over to the same side of the equation to get this equation. And now I'll just divide by 2 to get that secant cubed of x is equal to 1/2 the natural log of secant x plus tangent x plus 1/2 secant x tangent x plus our constant of integration. Alright, so now let's talk about integrating powers of secant and tangent x. Again, let's assume m and n are non-negative integers, and we want to integrate tangent m of x secant power n of x dx. To do so, we're going to use one of these 3 procedures. The first one is when the power of secant is even. When it's even, we're going to replace our secant squared x with tangent squared x plus 1 and making the substitution u equals tangent x. Now when we do that, du is going to be secant squared x dx. So I'm not going to convert all of my secant squareds. I'm going to leave one set of secant x unchanged. Now for the case where the power of tangent is odd, I'm going to peel off 1 power of tangent and rewrite the remaining powers in terms of secant using the identity tangent squared x equals secant squared x minus 1, and then I will make the substitution u equals secant x. If it turns out that the power of secant is odd and the power of tangent is even, then we will use the identity tangent squared x equals secant squared x minus 1 and reduce everything down to powers of secant. So let's look at some examples. In our first example, let's evaluate the integral of tangent squared x secant to the 4th x dx. Now here we have that the power of secant is even. So what we're going to do is we're going to peel off 2 powers of secant and rewrite the remaining powers in terms of tangent. So here's the integral we started with. I peel off 2 powers of secant x, and here's the remaining. I rewrite the remainders in terms of tangent using the Pythagorean identity. And then I go ahead and make my u substitution. I let u be equal to tangent of x, which means that du is equal to secant squared of x dx. Plugging those in to our equation, we end up with u squared plus u squared times u squared plus 1 times du. So now we just expand out our integrand. We know how to integrate this. And to finish up, we substitute in u equals tangent x to get our final answer. In our third example, let's integrate tangent cubed x times secant cubed x dx. So here we have that the power of tangent is odd. So what we're going to do is we're going to peel off one power of secant and rewrite the even powers of tangent in terms of secant by using tangent squared x equals secant squared x minus 1. So here I've peeled off one power of secant and one power of tangent. So now my powers of tangent are even. I rewrite those in terms of secant using the Pythagorean identity. I make my substitution of u equals secant x. That tells me du is equal to secant x tangent x dx. I make my substitution in, and I get that my integral is equal to the integral of u squared minus 1 times u squared du. So now we just go ahead and expand our integrand. We know how to integrate this, and then we plug in our value for u, which is secant x, to get our final answer. In this example, let's look at the integral of tangent squared x secant x dx. Alright, so here we have the power of tangent is even and the power of secant is odd. So what we're going to do here is we're going to rewrite the even powers of tangent in terms of secant using the Pythagorean identity. So here we've taken tangent squared x and replaced it with secant squared x minus 1. We go ahead and distribute the secant x across our terms. And we know that the integral of secant x is equal to the natural log of secant x plus tangent x. So now all we need to find is the integral of secant cubed x dx. We know from example 1 that that integral is equal to this. So just plugging this into what we want, we get that the integral of tangent squared x secant x is equal to, here's where I plugged in for the integral of secant cubed x, minus the natural log of secant x plus tangent x plus c. And we're almost done. If you look, this term here and this term here are the same, so we'll combine those to get our final answer. So here's a final remark. We've talked about powers of sine and cosine and powers of secant and tangent. We can make similar arguments by using this Pythagorean identity for solving things that are in the form cotangent to the power m of x times cosecant to the power n of x.